Hello engineers, welcome to my YouTube channel, Vision. The topic of discussion is irrigation engineering and the subtopic is water requirement of crops. Now as far as various exams are concerned, this topic is generally asked in every exam, say Engineering Services Gate, State, yes, and SSC, J. Now in this video lecture we'll be learning a concept with the help of a question. And the question is, find the time required to cover an area of 0.1 hectares when a tube well is discharging at the rate of 0.03 cubics for irrigating rabi crop. Average depth of flow is expected to be 7.5 centimeters and average infiltration rate for this soil may be taken as 5 centimeters per hour. Let's start with the answer. First, writing all the given values. Area is given as 0.1 hectare. Q is given as 0.03 cubics, that is meter cube per second. And the average depth of flow is 7.5 centimeters, that is Y. And the last one is average infiltration rate. Now, average infiltration rate can be defined as speed or velocity at which the water enters into the soil. That is I as 5 centimeter per hour. Now, there is another term, rabi crop. These, if we talk about rabi crops, these crops are generally sown in period of October to December time and harvested in April to July. Now, as we can see, the units are not uniform because area is given in hectares, Q is given in meter cube, and the average depth of flow is centimeters. Taking the units and making them uniform, let's start with the Q. The unit of Q is meter cube per second. The other unit of Q is hectare meter per hour. Now, meter cube per second can be written as meter square per second. That can again be written as hectare upon 10 to the power 4 meter upon second can be written as R into 3600. Now 2's okay, this 0.36, that we can say 0.36 hectare meter per hour is the unit of Q. Now Q is given as 0.03 into 0.36. The value of Q comes out to be 0.03. That's 0.0108 hectare meter per hour. Y can be easily converted to meter, that is 0.075 meters Y, and the other value is infiltration rate, that is 0.05 meter per hour. So the question says find the time required. Now if we come to the time required, to irrigate an area, we have a formula for it, T. This is given as 2.303 into Y upon I log of 10 Q upon Q minus intensity into area. Putting all the values that we have, 2.303 into Y is this 0.075 I is given as 0.05 log of 10. We have already got 0.0108 upon 0.0108 minus I is 0.05 and area is given as 0.1 hectares. 0.1 hectare. Now, if we solve it, log of this. So the answer comes out to be 0.932 hours. Converting it into more relatable unit, that would be 9.32 into 60. Say if we convert it into minutes into 60, that comes out to be roughly 56 minutes. Okay. Now coming on to the second part of the question. The second part says for the problem, find the maximum area. They're asking for the maximum area that can be irrigated by the available discharge of 0.03 cubics. So let's understand this with the help of a diagram. We have a given volume. This is the volume. Now, this is the depth of flow. And if I change the color, this is the area that is supposed to be irrigated. Okay. Now, if we see the intensity or the infiltration rate is defined for this depth I. I is okay. I is basically directly proportional to volume of voids. That is, more in the volume of voids, more of the water will enter into the depth Y, and we can clearly see that the area that is supposed to be irrigated, that is A max, will be reduced because we have a formula of Q is equal to I into A. If the infiltration rate increases because volume of voids is more, so A max will be reduced. So in order to make A max as possible, we calculate it as Q upon I. Now we have got all the values up here. Q is 0.0108, 0.0108, and I is 0.05, 0.05. So 0.05. The area comes out to be 0.216 hectares. I hope you got with the second part as well. In case some of you are facing the difficulty, I would recommend you to go through this lecture again. And don't forget to subscribe because this is all for this lecture. Thank you.